All right. So last problem we finished on was 3A. Okay, so real quick. So just to kind of go over what we were doing yesterday. Okay. We started out with some velocity, acceleration, um, position type stuff, but essentially this is the three things we're doing: displacement, change in position. Okay. So integrate the rate of change over the interval, over whatever interval they give you. How far have you traveled or distance traveled? Integrate speed over that interval, okay? Because speed is just the absolute value of velocity. And then new position. New position means old position plus the change in the new position, okay? Which is displacement, okay? So the last problem, which we're not done with because we just did A, was situation where we have three things going on. First thing going on, tide is pulling sand away from the beach. So sand is leaving the beach. Okay. At the same time, you have a pumping station that's putting sand back onto the beach. Okay. And then it says currently at the start, when t equals 0, there's 2,500 cubic yards of sand there. Okay. So this is kind of what's going on here. If we want to know the rate that it's coming on, we use S of t. If we want to know the rate that the sand is leaving, we use R of t. Okay. And when t equals 0, there's 2,500 cubic yards. Okay. So we did A. How much sand will be removed? We use R of t. Why did we use, remind me, why did we use an integral for this guy? Because when I see how much sand, I just want to plug in 6 for R. Why did I need an integral for 3A? What was the reasoning behind using an integral instead of just plugging in 6? Yeah, you read? Total, yeah. Total accumulation. Good. Anytime you want to add up everything that's been going on, right? That's going to be an integral. It's like your cumulative GPA. Your GPA right now, you have two GPAs. You have the GPA you just got at the 6 weeks. That's your current GPA. But that doesn't really reflect what's really going on, right? You guys have been here since freshman. That's a cumulative GPA. That accumulates, right? Same thing. One's an accumulation. If I were to plug in 6, that would just tell me the rate at hour 6, a snapshot of 6. That wouldn't tell me the whole thing. Okay. So let's look at 3B. Okay. Same thing. Tide pulling sand, pumping station pumps sand in, still 2,500 at time 0. Okay. So what we have to do now is write an expression, y of t. Okay. So we have to write y of t. For the total number of cubic sand on the beach at time t. Okay. So they want us to write. Don't have to solve. We don't have to evaluate. We don't have to come up with a number. We just have to write a an expression or an equation, right? What does y of t equal to? The total number of cubic yards of sand at any time on the beach. So if I want to know after 2 hours how much sand is on the beach at that time, I can plug in 2, solve my answer. After 4 hours, how much sand is currently on the beach? I could plug in 4, plug it into my calculator, and I could get an answer. Okay, that's what I want. I want an expression that will be able to tell me that. Okay, so what am I going to need? What is it asking me to do? What is it asking me? What is it not? I know what it's asking me to do, find the total number. but in plain English or base terms, what is it asking me to do? What is this in count of? What is this? What's the words? Total number. What do I have to account for with total number? If I want to know the sand on the beach at that moment, how much sand, the total number of cubic yards of sand on the beach at any time, what do I have to take into account? Mhm. There you go, right? There's two things I have to take account of. How much sand is leaving or has left, right? That's a minus. How much sand is coming on? That's a plus. And what else? There's one more thing. Exactly. How much sand was already there to begin with, right? That's the three things I have to account for if I want to know at any time. So in other words, this is what I'm doing. In other words, let's see, in kind of basic terms, I need the initial amount, right? How much was actually there at the beginning? The amount added. We just talked about, right? We talked about three things. The amount that was already there and the amount added. I'm going to add that number, right? Because that is included. Amount added. So let me write this over here. Okay. The amount added. Okay. And then what am I leaving out? I got the initial amount that was already there, plus the pumping station. And then what am I missing? The stuff leaving, right? So what am I going to do? Am I going to add the stuff leaving? No, I'm going to subtract it, right? I'm going to subtract the amount leaving or removed. That's essentially what I need to do. I need to create that equation there. Okay. Well, we have values for that. Okay. Initial amount. What is that? Do I have a number for initial amount? 2,500. Okay, so let's do that. 2,500 plus, use another color, amount added minus amount leaving. How do I figure those out? How do I figure out the amount added over a time and the amount leaving over a time? Yeah, you're right. There you go, right? I'm going to have to find the integral of both and subtract them, right? I'm going to have to find the integral of both from 0 to whatever time. I don't know whatever time. They didn't tell me what time. So it would be t for r of t. And then the integral, same thing here. Right? And I got to subtract them. Well, instead of having, you can have them separate like that, or you can put them together because they both have the same bounds. So you can say r of t minus s of t dt. I ran out of room there. Oops, I got more room. Okay. This is the amount leaving. This is the amount staying, or that's being added. So you could keep them separate. I can also keep them separate. Okay. Give me 1 second. Okay. You could also keep them separate, or you can Do you guys know what I mean by keep them separate? They each get their own bounds. You could do this. All right. But I combine them since they both have the same bounds. I combine them like that. Okay. That is what I would use. And I'm going to use that in a little bit. That's something that's pretty big on the AP test, creating something and then using it, right? It's a double whammy because if you don't create it, you can't use it. So if you don't create it correctly and you use the wrong one, you're going to lose out on multiple points. So you got to be able to create something and then be able to use it. Okay, we're gonna use it in a little bit. Okay, looking at last night, I had a couple extra minutes, so I was like, you know what? Let me go look up the last 5-6 years of the AP test. I didn't count the last 2 years because that's the COVID years, and they've been doing something different. But this year, they're going to go back to what they always do. They're going to go back to their regular system. So I looked at the first year that COVID wasn't an issue, and I went back 4, 5, 6 years. Every year, number 1 or number 2 in the FRQ was a question like this, right? Something going in, something coming out. Like one year was Disneyland tickets. Disneyland, the amount of people who go to Disneyland. Coming in, going out, how many are there at the beginning? The year before that, it was people who get in line for an elevator. People get in line, people leave line, people in the elevator, right? Every year there's been a problem like this. And every year they always want you to create something, just like we did here, and then use it. Okay? These are always calculator questions. So these are extremely important. If there's one thing I guarantee will be on the AP test, and our test when we eventually take it, will be a question like this as an FRQ question. Okay? Because these are so popular within the last 10 years. Okay? Okay, so letter C. Find the rate at which the total amount of sand on the beach is changing at time 4. What do I do there? This is what I'll get. Oh, plug in 4 to R. Or plug in 4 to S. And that's my answer. Why is that not right? It's the rate, right? It says the rate. It says the rate right here. Rate. And aren't these the rate? Aren't those the rate? So I'll get people just plug in 4 here, or plug in 4 to one, plug in 4 to another. Why is that not right? Or is that right? Think about it for a second. I don't want to tell you the answer because I think some of you aren't thinking enough for this because you really got to get to high level. Okay? I can't teach you to think, but you can think. You're all extremely smart people. I want to give you some time to think about that. How do I find rate? Read this question, formulate a plan. A plan doesn't mean the answer. Plan doesn't mean the answer. Plan just means look for keywords. What are we doing? Okay, I'm going to give you about a minute. Think about it. Just think about it for a second. Just think about it. Okay? There's some keywords there that are going to help you to solve the next problem. Sometimes it takes a little bit of thinking. Buzzwords meaning keywords, key terms that are going to help me. Right? Sand on the beach. That's just in context, right? That's not going to help me. What are words that will help me though in that? What are words that will help me figure out what's going on here? Yeah, you wrote total amount. Yeah, just mostly total amounts. Total amounts. If we're looking for total amount, what does that insinuate? Total amount. What does total amount insinuate if I say total amount? Mm-hmm. Yeah, so if you see total number, total amount, integral, integral, because that means if you're totaling something, it means you're adding something up. In calculus, that means integral. We're going to use an integral. Okay? Okay, we got that one. Integral of what? This means integral. Integral of what? Integral of what? We know we're going to find an integral, but of what? Yes, sir. There you go. The integral of y of t. The integral, or y of t, I should just say, because y of t is an integral, right? Y of t is already an integral because it has it. Okay, good. We're going to use y of t. Good. What are we going to do for y of t? There's another buzzword in there. There's another buzzword in there that we haven't yet talked about, but it's important in terms of what we're going to do. That's y of t. What's the other buzzword in there that we haven't talked about? That no one's mentioned yet. There's only so many words in there, and I think you guys know. Don't want to say. We said total amount of sand. That one we're done with. What other words have we that are in there, that are in here, that are in letter C, that are going to be important as to what we're doing? There, there you go. The rate. The rate. Okay. What's another word for rate that we've used? What's another word for rate that we've used a lot, especially first semester? The rate. Hmm? Derivative. Yeah, dy over dx. Derivative. When it says find the rate, that means you're finding the derivative of something, right? You're finding the derivative of something. Well, we've already said we're going to find we're going to find the total, right? We said total, so that's why we had y of t. Rate means we're finding the derivative of it. Okay, so the derivative, let's find the derivative of y of t. Y prime of t. What's the derivative of 2500? Anybody? No? Zero. Yeah, why is it zero? Answer now or answer later. That's what I tell my math 3 class. Answer now. It's not going to be on the test. There you go, because it's a constant, right? Okay. How do we find the derivative of the integral? How do we find the derivative for the integral? Yep. So what do? The integral is going to go away. This should look familiar, hopefully. You saw it on your last test. This guy right here. When we see this here and we find the derivative of this, what happens to the top? Goes there. It goes there. Second fundamental theorem, or fundamental theorem part 2. So we have r of t minus s of t. No more dt. Okay, that's the derivative. Now, what do we do with the derivative?
I have a question.
Yes, go for it.
S of t is adding, so it'd be S of t minus R of t.
Did I get the letters mixed up? So S of t. Yeah, you're right. I got the letters crisscrossed. Mess. I got R and S. S is adding. R is. Thank you. Yep. That is definitely something you need to change. S is adding. R is taken away. So yeah, we want to subtract the taken away. We want to add the part being added. Okay. S R. Okay. Thank you. Yeah, that's definitely important. Okay, so what do we do now? Found the derivative. How do I find the rate now at when t equals 4? Plug in 4, yeah. Remember when I said at the beginning? Is that what we do? Maybe it is. Why is it not? Well, apparently it is, but we couldn't plug it in at the beginning, but we had to find the derivative first. So 0 s of 4 minus r of 4. Okay? So plug in 4, plug in r, or plug in 4 for r, plug in 4 for s. What do you get? You got a calculator. That's why this is a calculator question. Use your calculator to figure out what you would get when you did all that. Approximate it. Okay. This is good practice. This is good practice using the calculator, because the next test you will be able to use a calculator on everything. It'll be a calculator open question, open test. Calculator is great, but you got to have to use it. You have to be able to rely on it and use it. So this is good practice to see if you get the right answer. Okay, so the answer you should have gotten when you plugged it in and subtracted those two is negative 1.909. Negative 1.909. Plug in the S first. Plug in the R, because good thing Sebastian brought that up, because if we didn't do that, we didn't switch them, we wouldn't have gotten the right answer, because we would have been subtracting the wrong order. Okay, but S is the added, R is the taken away. So we got to plug in for R, plug in for S, plug in for R, subtract. We get a negative number, negative 1.909. Units, though, what units would that be? It's a rate. So it's going to be over time. It's going to be units over time. So what type of units are we using here? Something over something. What over? Yep. Mm-hmm. Say it again. There we go. Cubic yards, because that's what it's being measured in, right? And it's over time. What unit of time are they giving us? Hours. Okay. So what does that number mean? Why is it negative? What does that number mean?
The amount of sand is increasing.
Exactly, right? At hour 4, there's actually more sand leaving the beach than being added to the beach, right? The pumping station is pumping, but it's not enough. It's actually, there's more leaving the beach than actually being on the beach by almost 2. They're losing every hour. They're losing almost 2 yards, cubic yards, 3 by 3 by 3. Okay. Okay. So let's look at letter D now. Letter D. Oh, there we go. Okay. All right. So letter D says same setup. Okay, 0 to 6. So from hour 0 to hour 6, and everything in between. At what time T is the amount of sand on the beach a minimum? What is the minimum value? How do you know that? Justify your answer. Buzzwords. Underline, circle, highlight, whatever you do. Buzzwords, always, always, always. When you're doing free response, especially if you don't know what your first step's going to be, always do that because that'll lead you to your first step. Okay? Reading that, there's a lot of buzzwords, a lot of things that should jump out at you. What's the first thing that jumps out? Minimum. That's the one that kind of jumped out at me. It's written twice, and I've seen that word lots and lots and lots of times. I've seen it on at least 2 different tests that we've taken. Right? Minimum. How do we find a minimum? If I wanted to find a minimum value, how have we done it in the past? How have we always done it? What do we do? We've done it plenty. What have we always done if we need to find a minimum value? Mhm. How do we find the critical values? What do we do first? There you go. Find the derivative, right? Find the derivative. So we're going to have to find a derivative. We know that. Okay? Question is derivative of what? Yeah, y of t. You're right. We're going to find the derivative for y of t. Why is that? Why is that, Sebastian? What made you go y of t? There you go, right? Right there. The amount of sand on the beach. I already did that, right? I already did a y of t for the amount of sand. That's another buzzword. Amount of sand on the beach. I've already used y of t. And that's what it was for, okay? So what we're going to be doing is we're going to be using the same thing, the derivative, right? So we're going to be remember y of t is this, 0 to t, s of t minus r of t dt. That's what y of t was, right? We created that a couple problems ago. So now we need to find when the derivative is equal to 0. Okay, so let's find the derivative. We just did that in the last problem, right? The derivative was 0 plus s of t minus r of t. Set it equal to 0. How do we solve for 0? How do we find out? Here's my question. How do we find out when s of t minus r of t equals 0? There's a couple different ways. Several, in fact. How do we figure that out? I can't factor it because neither of those are quadratic, or neither of them are polynomials. One's a trig function and one's a rational expression. So how do I figure out where this equals 0? Mhm.
You can also do RT equals S of T.
Yeah, we got to find out where they're equal. Yeah, that's a good point. We do. If we can figure out where they're equal, where they have the same y value, for what x value or t value are they equal, we could definitely do that. How could we do something like that? How can we do something like that? I'm not necessarily looking for a method. I'm looking for just how. What do we do? What do we do? How do we figure out when a function equals 0? Because this is a function, right? How do we figure out when a function equals 0? What's the easiest way to figure out when a function equals 0? Think about it for a second. I would say a graph would be the easiest way, right? When it crosses the x-axis, boom, that's 0. So these guys are pretty ugly. Do we have a way to graph them really easily? Do we have a way to graph them really easily? Yes, that thing on your desk is not a paperweight. Okay, it's a graphing calculator. It will help you graph it. So we have to put it into our y equals. So we're going to graph it. Okay, so let's go. Okay, so if you want to graph something, you got to go to y equals. In this class, we always graph with y equals. Stats, we graph somewhere else. But this class, we always graph with y equals. Okay. Before you graph, though, my stats class uses these every single day. That's one of the nice things about statistics. From day one to the last day and everything in between, you can use a calculator. In this class, you can use a calculator about 20% of the time. Stats, you can use it all the time. So they use it a lot. They graph a lot. So if your graph might mix with their graph and the calculator doesn't like doing that. So the way to check that is to go stat plot right above it. See right above y equals stat plot? Go to stat plot. If number 1, number 2, or number 3 say on, turn them off. Turn them off. So number 1, number 2, or number 3. If they say on, turn them off because it's going to graph it. So how do you turn them on? You hit enter, you hit off, and you're done. That easy. Okay, so make sure everything says off. Otherwise, the calculator might freak out because it's graphing more than one thing at a time. Okay, super easy. So we want to graph S minus R. Okay, what is S? Type in S. Okay, type in S. Type in S. Riley, can you put the phone away, please? If you want it, you can keep it on your desk, but don't hide it because it makes me think you're not paying attention. Okay, if you want to keep your phone on your desk, that's fine. Okay, type in S. S is, I always put parentheses. I use a lot of parentheses because I want my calculator to be able to do everything. What happened? What just happened here? 15x parentheses divided by, and then the bottom, 1 plus 3x parentheses. And in fact, I'm going to put those in parentheses. So I'm going to go back to the beginning. And I'm going to put insert more parentheses. And at the end, I'm going to put more parentheses. That's S of t, right? And then I'm going to put a minus, R of t, parentheses, 5, sine. Okay. Oh, sorry, forgot about the 2. Insert 2 plus, okay, 4 pi RT parentheses divided by 25. Close parentheses. Close parentheses. Always close. So if you open a parentheses, make sure you close it. I had one at the beginning. I have one at the end. Then I have one around my sign. Oh, actually, I need another parentheses. So I had one around the whole function, and then I had one around my sign, and then I had one around this guy. Oops, I need to put another parentheses in there too. So I put a parentheses around 25. Because if you don't close them, if you open a parentheses and you don't have another one to close it off, the calculator won't do what you want it to do. Okay? And do you need all those parentheses? I always do. Because your calculator knows PEMDAS really, really well. And sometimes they might divide when you actually want to multiply first. Like I want it to multiply 4 pi x first, get an answer, then divide by 25, and then take the sign, right? That's what I want it to do. So I want to be very direct with my calculator so that there's no chance it could mess up. Okay? So when you want to graph in this class, you go to zoom, you hit the zoom function, and then you go to, there's a couple different ones you can go to. I use zoom decimal. Zoom standard works too. Okay? Zoom standard, zoom decimal work. The one I use all the time is zoom decimal. That's because that's the one I was taught. So that's the one I use. Okay? So if your calculator is not giving you something that looks like my picture, it's probably because something in your function there wasn't a parentheses, there wasn't something like that. Like I said, calculator is very touchy with those things. All calculators are. Desmos is, TIs are, they're all very touchy with parentheses and everything like that. Okay? Okay. So let's kind of zoom out. Anytime you want to zoom out, you can zoom out, go to zoom, and see the bigger picture if you want to. You can go to zoom, zoom out, and then it's going to ask you, where do you want to like zoom out from? Where's your perspective point? Do the center. Okay. Okay. So if your calculator is not cooperating, don't worry about it. Just look at mine. Just make believe your calculator is my calculator. Okay. If your calculator is doing it, do it on your calculator. If you got it, use your calculator. But this is the most important thing of everything we're doing today. Where do I look? Calculator graphs. Does a great job of graphing. But how do I use it in this case? What am I doing? What am I looking for? Trying to find the zeros, yeah. When I look at a graph, where are the zeros? Anytime you say zeros on a graph, where should you look? Where should your eyes go? Mm-hmm. Where it crosses the x-axis, yeah, exactly. It crosses the x-axis. It crosses it here, crosses it a whole mess of times, right? Crosses here, crosses here, crosses here, here, maybe here, 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 and here. Do I care about all of those points? Do I care about all of those points that it crosses? No. Good. Where's the only spots that I care that it crosses the x-axis? 0 to 6. There you go. So I'm going to go zoom back in. I'm going to go zoom back in closer to where that is. So zoom in, and I'm going to scoot over right about there. That's where I want, right there. You see here, it doesn't quite hit the x-axis here. So right by the origin, in fact, it doesn't. So we don't have to worry about that guy right there, right? But this guy over here does. So let's figure out what that 0 is. Let's figure out what that 0 is. So your calculator will do a pretty cool function. It'll tell you where the zeros are at. How do you do that? Well, go to calc. Right above trace is a calc. Go to calc. Second trace. And your calculator will say, what do you want to find? What do you want me to calculate? What do you want me to do? I want a 0. Okay, so where's the left side of the 0? Right there. Where's the right side of the 0? Let me go past it. Right there. Where's your best guess at what the 0 is? Right there. And there it is. 5.1178653. That's my critical point. So I'm going to write that down. That's my critical value. My critical value, I have one of them. 5.11, go 3 spaces past the decimal and you're good. 5.118, done. Okay, that's almost 6. So let's go to 6. We can scroll down to 6 a little more. That's 6 right there. So from 0 to that cursor is 0 to 6. It only crosses one spot. So that's the only spot I care about, that 5.118. Okay? All right, so let's go back to the notes. We're getting closer. So I got a minimum, or I got a critical value there. Okay, we've done that before. Anytime they give you an interval, even though they don't use the words, it's automatically assumed they want an absolute minimum over the interval, right? Anytime they give you an interval, it's automatically assumed. So even though they didn't put absolute minimum, they want to know during that time what was a minimum, what was a low point. So definitely we're going to check. So we have T and we have, what's the other one? Y, since it's Y of T. We check this guy. What else do we check? When we're checking for absolute minimum or absolute maximum, what else do we check? 0 and 6, the beginning and the end. So the last thing we're going to do is we are going to plug those points in. Where are we plugging these points into? For T, I know that, but where? Which T? Which T are we plugging it into? Because I see T's everywhere. I see T's here, 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 here. Which one are we going to plug it into? Yeah, Ira? Yes, the original. The original. You're going to plug it back into the original. Okay? For time purposes, I'm going to skip ahead to the calculator. So when you plug in, so this is what you're going to do. So if you want to go watch this video again, you're plugging in each of these values here into here, here, and here. Okay, you can do that on the calculator, but since we're running low on time, I'll tell you what you're going to get. You're going to get, for this guy, you're going to get 2,500. No, sorry, for 0, you're going to get 2,500. Because when I plug in 0, you're finding the area of no bounds, nothing, right? So that's why it's 0. So it's just 2,500. When you plug in 6, you get 2493.277. When you plug in 5.118, you get 24 92.369. Make sure you understand that. If you don't, go back and watch this. Go back and watch the video as to how we did this. Okay? Take your calculator, plug these number in to the original for T. Take this guy, and that's how I got those. So that's just calculator. You guys could do that if we had 5-10 minutes extra. You guys could do that on your own. But since we're running low on time, I wanted to give you. So what's the absolute? Here's the question. A lot of you missed this because of this on the test, because I did ask you an absolute minimum question. What's the absolute minimum? Yep. Exactly, the y value. So which of these y values is the absolute minimum? It would be this guy right here, yeah. So you would say the minimum value is there. The minimum value is 2,492.369 yards cubed. And when does that occur? When t equals 5.118. Okay? The absolute minimum from 0 to 6 is 2,492.369 yards cubed. And that occurs when t equals 5.118 hours. That's what your answer would be for this one. Okay? All right. Again, this is taking us a while. It's okay. It's okay. I'd rather take some time here. And then I'm going to give you some time to actually do these next week. I'm going to give you some time to actually play with these because there's a lot of examples. Because again, it's covered a lot in the AP test. Okay, the next one we're going to do on Monday is the same type of problem, but instead of functions, they give us a picture. Same thing, right? That's what we're going to do. All right.